Back at Honors Algebra 2 and Pre-Calc. This is Pre-Calc Chapter 6.3. We're doing more visuals of vector operations. So here is example 6. Let vector w be the vector -1, 3, and vector v be the vector 2, 4. Draw a visual and find the component form of each one of these. So I kind of cheated and already made grids that are going to fit what we want, but that's cool. So we're going to do vector w in red. Okay, so vector w, 3 of vector w literally means vector w plus another vector w plus another vector w. So vector w starts at the origin. It goes left. Right, left is tragic for my brain. It goes left 1 and up 3. So this is my first vector w, right? That little red vector. And then I'm going to do it again because I'm adding 3 of them total, right? So I go left 1 and up 1, 2, 3, and there's my second vector w, right? And then I do it again, so I go left 1 and up 1, 2, 3, and there's my last vector w. So what it ends up looking like is essentially this segment, or rather this larger vector that is just the same vector, like mini vector 3 times, right? So this is w plus another w plus another w, right? And so we can see just visually that the component form is going to be -3, 9, right? But you could also see that if you had just found the component form the old school way that we found it in examples 3 and 4, which is that 3w should be 3 times a -1, 3, which means that 3w is a -3, 9, but again, that's just confirmed visually by our graph. So that's A. Part B, -2v. Now this is tricky because it's the opposite direction of v. So what I want you to notice is that if v, right, is 2, 4, then -v is literally going to go the opposite direction. So -2, -4, right? Which means -2v would end up being a -4 and a -8. But what I want to show you, so that's my -2v, right? But the reason that's relevant is what we're going to sketch the opposite of v twice, right? That's what -2v is. It means go the opposite direction of v twice. So the opposite direction of v, instead of going instead of going right 2 and up 4, I'm going to go left 2 and down 4. So left 2, down 1, 2, 3, 4. That's an opposite of v, right? That's -v. And then I do it again. I go left 2, down 1, 2, 3, 4. That's my -v again. And that's how I get a -2v. I do -v, right, twice, okay? So, again, I didn't graph v, I graphed -v because it was in the opposite direction of v. Now, if we do w minus v, right, I'm going to graph w first, right, the same way I did over here, which is going to go left 1, up 3. So there's my w from the origin, left 1, up 3. There's w. And then remember, we add vectors head to tail. So now I'm going to draw -v, which we already established is a -2, -4. So from here, I'm going to go left 2, down 1, 2, 3, 4. And I'm going to land here. And that makes my resultant vector, right, my w minus v, is going to be this resultant vector, w minus v, right, which is going to go left 3 and down 1, right? So it's left 3, down 1. Now, you could have also figured out that it was left 3, down 1 in the same method that we did in E3 and E4, right? The other way to get this would have been to say, oh, I get it, it's w minus v, so -1 minus 2, comma w minus v, which would be 3 minus 4. Okay, that's a -1 because sometimes my brain is slow. It's below the axis. Come on, brain. Anyway, so you get the gist that either way I get -3, -1, again, if my brain had been functioning properly. So that's your example 6 of the visual going with adding and multiplying vectors.